Hello everyone. Today we're going to do a packages of CCNA3 version 7, 2.4.11. Packages modify single area OSPFv2. This is an addressing table, objectives. In this activity, OSPF is already configured and all end devices currently have full connectivity. You will modify the default OSPF routing configurations by changing the hello and dead timers and adjusting the bandwidth of a link. Then you will verify that full connectivity is restored for all end devices. Part 1. Modify OSPF default settings. Step 1. Test the connectivity between all end devices. Before modifying the OSPF settings, verify that all PCs can ping the web server and each other. Let's go to PC 1. Start from here. We ping from PC 1 to PC 2. Yeah, in the beginning, it takes a little bit longer time. Where the one time is the timeout, that's okay. It's connected. Then we ping from PC2, PC1 to PC3, PC1 to PC3. Good. Then ping PC1 to server, web server. Okay. Ping. Okay, PC1 is done. PC2, we ping from PC2 to PC1. Okay, it's good. Then ping PC2 to PC3. Good. PC2 to web server. Good, PC2 is done. Then go to PC3. So from PC3 to PC1. Ping. Yeah, connected. So from PC3 to PC2. PC3 to PC2. The last one, PC3 to web server. Okay, perfect. We finish this part. Finish this step. Step 1. Step 2, adjust the hello and dead timers between R1 and R2. R1 and R2. Enter the following commands on R1. These commands. Let's go. All right, so enable config T interface S000 IP OSPF hello interval 15, IP OSPF dead interval 60. By default, the dead interval is 4 times of hello interval. 15 times 4 equals 16. Okay. After a period of time, the OSPF connection with R2 will fail, as shown in the router output. So the OSPF between R1 and R2 will fail. We will see, here the message come out, OSPF5 adjacency change. The 5 here is the syslog severity level, level 5 notification. So here S00 is down. Interface is down. So S00 is this interface between R1 to R2. R1 and R2, this interface is down, okay. Both sides of the connection need to have the same timer value in order for the adjacency to be maintained. Identify the interface on R2. Identify interface on R2. This interface S000 to down, okay. So this interface is down as well. This interface is down, this interface is down. That's correct. Adjust the timer on the R2 interface to match the settings on R1. All right. So we need to adjust. Before I adjust the timer on R2, I want to show you the current timer on R2 and to compare the timer between R2 and R1 to see the difference. Interface. Okay, here, R2, this interface 000, the timer hello 10 dead 40. But here on R1 is hello 15 dead 60. So these two ends of this link, the timer are don't match. So we need to adjust the interface on R2 to match R1. So config terminal interface S000 IP OSPF hello interval 15 IP OSPF dead interval 60. All right, we adjust it. After a brief period of time, you should see a status message that indicates that the OSPF adjacency has been re-established. Okay, here, the message come out. Serial 000 from loading to full, loading down. That means it's re-established. Good. Let's go to step 3, adjust the bandwidth setting on R1. Trace the path between PC1 to the web server. Notice that the path from PC1 to server is routed through R2. OSPF prefers the lower cost path. Let's go to trace from PC1 to server. Tree search server 100.1.2. Okay, from here we'll see the path from PC1. There are 4 stops: PC1, R1, R2, and the internet and the server. Okay, 4 stops: R1, PC1, R1, R2, internet, web server. All right, so 4 stops, remember that. And on R1 serial 000 interface, set the bandwidth to 64 kilobit per second. This does not change the actual port speed, only the metric is cost that the OSPF process on R1 will use to calculate the best routes. This command on R1. All right, so before I change the bandwidth on R1, I need to show you all the cost, the cost of each interface on R1. Then we change the bandwidth. We will compare how the bandwidth changes the cost and how the cost changes the path. OSPF interface, okay, here. The R1 is 000. Right now, the cost is 64. 001, 64.2. Look at the topology. So this link is 0, this link is 64, the cost is 64. This link, the cost is 64 too. So these 2 links have the same cost. Let's change the bandwidth. So 000 on R1. Bandwidth is 64. All right. So let's take a look. Let's see how the bandwidth changes the cost. Interface, okay. Here now, the link, the serial 000, this link, the cost changed to 1562. 1562. And this link is still 64. 64. Okay, let's trace to see how the path they changed. All right, so here they changed. Before it's 4 stops from PC1 to server. Now it's 5 stops. R1, R3, R2, internet, web server. So now is PC1, R1, R3, R2, internet, web server. So it's 5 stops. So the path changed. Before is PC1, R1, R2, internet, web server. So the changed is because this link, the cost is 156. This link is 64. The OSPF always take the path with a lower cost. So that's why the path changed. All right. So I look at the completion status 100%. That means we are done. But last part 2, verification. Verify connectivity. Verify that all PCs can ping the web server and each other. I'm not going to do this part because this will be done in the same way as we did at step 1, the ping each other and ping server. All right, So we're done for these packages of modified single area OSPF v2. Thank you for watching my video. If you like and think it's helpful for you, please thumbs up and share with your friends and subscribe my channel as support to me. See you next time.